So, good morning, esteemed colleagues. I am Matilde Boschiero, a radio navigation engineer at Quascom, an Italian-based company focused on space receivers and authentication. And I'm going to briefly, but hopefully interestingly, present to you the long journey towards the development of the lunar GNSS receiver experiment called LuGRE. First of all, let me express my deepest gratitude to all the colleagues in the LuGRE team for the incredible effort put into this work so far and in the periods ahead. So shall we? Next slide, please. There's no other slide. Thank you. So LuGRE is a joint project between NASA and the Italian Space Agency, ASI, that aims to develop a GNSS receiver able to acquire GNSS data throughout its journey to the moon. LuGRE is part of the next commercial lunar payload service flight, who is boarding 10 commercial payloads provided by both the industrial and the academic world. Therefore, the LuGRE receiver has been modeled according to the strict do no harm regulation imposed by NASA. And LuGRE and the other payloads will be boarded in the Firefly Blue Ghost Mission 1, landing in Mare Crisium after 40 to 50 days of transit. Next slide, please. So LuGRE experiment relies on the legacy built by the 90s early discoveries, as well as NASA magnetospheric multiscale experiments. LuGRE's purpose is then to benefit from the previous achievement and to push forward. It has been developed to receive GNSS signals from above LEO to the lunar surface and demonstrate the potential of GNSS technology in both lunar and cislunar environments. With this mission, we hope that LuGRE will help make the case for the development of next GNSS space receiver. Next slide, please. The LuGRE payload is composed of a high-gain antenna, a front-end assembly, and a moon-customized version of the Quascom Quen 400 space GNSS receiver. The antenna is a right-hand circle polarized passive L-band high-gain antenna, manufactured by HIFAR, operating in both GNSS band and in cascade with the front-end assembly consisting in a low-noise amplifier. Next, in the LuGRE design scheme, there's a Quascom Quen 400 space GNSS receiver. This is a state-of-the-art dual-frequency L1F5 multi-constellation receiver designed in a dual-code redundant configuration managed by a supervisory board in order to tackle the severity of condition in the moon transfer orbit and lunar environments. The receiver has been developed by Quascom in the frame of its consolidated and fruitful cooperation with ASI, and the result is a robust, low mass and power efficient design that enables LuGRE to withstand the lunar environment and to achieve the next GNSS fix on the moon. Thank you for your time and attention, and for any question, please contact me.